One of the things we've been saying all along here is provided the limit exists. So that limit as h approaches 0 that we've seen before, it may not exist, and usually it does it when the graph has some certain things on it. What these things are is when the function is undefined, has a sharp corner, or a vertical tangent. In the first graph that I see down here, this graph has a vertical asymptote. Because it has a vertical asymptote, that means that this function is not defined at x equals 0. Well, any function that is not defined somewhere, the limit as h approaches 0 for the derivative, we won't be able to do it. And so we'll say that the derivative then doesn't exist at x equals 0. But it does make sense in other places because I can draw a tangent line on there. The only place it doesn't make sense is where it's undefined, which in this case was at 0. This next function is an absolute value function. It has a corner at 0. So if we try and find the derivative through that limit definition, it's going to come out to not work at that point right there. Now in the third graph, this one also does not have the derivative existing at x equals 0 because if I draw the tangent line here, it's vertical. And if you try and find the slope of a vertical line, you'll get undefined. We can have a derivative not making sense because the original function's undefined, it has a corner, or a vertical tangent. Sometimes you'll try and actually do this, and remember that middle graph was just absolute value of x. Well, I told you that the limit didn't make any sense, but let's just go ahead and try it ourselves. If I want to find the derivative, so there's the prime, at 0, I need to do the limit as h approaches 0 of f of 0 plus h minus f of 0 over h. So I need to put 0 plus h into the absolute value and 0 into the absolute value and subtract it. When I put 0 plus h in place of x, I get the absolute value of h. F of 0 is 0, so on the top of my definition here I have the absolute value of h minus 0, all divided by h, which is really just the limit as h approaches 0, absolute value of h over h. Depending on how you approach h here, do you let h approach 0 from negative values or positive values? Well, if you let h approach 0 from positive values, so we're going to have a positive number inside of the absolute value divided by the same positive number, well, this fraction will come out to be 1. If you have a small negative number into here, the top will come out to be positive, the bottom will be negative but the same, so when you divide it out, that's going to give you negative 1. Since h can approach 0 from either positive or negative values, the limit is either going to equal 1 from the right or negative 1 from the left, so your one-sided limits don't come out to be the same thing. So that means the limit does not exist, which means your derivative does not exist at the point x equals 1.